All right, so continuing our exploration of base 12 geometry and the geometry of the circle. I'm just going to go over a few points for how we got to this point here. We're at the edge of a diagram that's dividing the circle into 360 degrees. So at the very beginning of the series of videos, I introduced you to the idea, or I explained what the difference is between base 10 and base 12, how the Cartesian plane is denser, how the decimal places are the place where the real difference is. 0.1 in base 12 is a shorter, smaller unit than 0.1 in base 10, because we're dividing the 1 up into 12ths instead of tenths. So it's really in the division of the 1. The 1 is the same size in base 10, 0.1 is a certain size, in base 12 it's a little bit different. So we're working in units of duodecimal or base 12, so smaller size decimal places. So all of our lattice points, we are working with lattice points, fixed points on the XY coordinate plane, but they have a different relationship to each other. These are lengths that we never worked with before as actual lattice points. So using that diagram, or using that coordinate plane, base 12, and a diagram emerged, or a pattern emerged, the dodecagon, this 12-sided shape where all of the lengths are in units of 0.5 root 2. Again, 0.5, a duodecimal length, root 2. So again, something that we never had access to before in relation to the 1. I showed you how you can draw it out just on graph paper, and when you line up the base 10 1 or the base 12 1, it lines up differently to that pattern. So we use that pattern to start drawing circles, creating a diagram where we were able to divide the diameter of the dodecagon into its perimeter. And then as we did that, we realized it's becoming the circumference of a circle. So we did a sort of like a backwards version of dividing up the circle. Usually when we're talking about pi and putting the radius into the diameter or into the circumference as radians, or the diameter into the circumference, this division process has always been a little bit difficult. We're starting with the full circle and then dividing it up. Here instead we're starting with a very small, like the heart of a circle, and then we're adding more, we're growing the circle. And each time we grow, we're growing in units of 12, so it's a base 12 relationship to the circle itself. And these are the consecutive rings as we get larger and larger. And we realize that on the 30th ring, this is when all the basically lines line up and we get 360 degrees, because we're working in 12s, we're working in 15s. It all basically lines up, but then we can keep going. This is the thing to remember. Now, this is the halfway to that 30th ring. This is the 15th ring. The angle inside here, we went over this. We've drawn straight lines between all these small circles, and there's an angle that's formed in the center of each of these circles. At this ring, it's 179 degrees. That's base 10. So the next ring, the 30th ring, is 179.5 degrees. So half a degree from straight up and down 180, but we know it doesn't actually get there for a very long time, if ever. I'm going to think about that right now, though. What happens is we continue making these rings. Like at this point, we're at 179.5 degrees. The circle itself, its actual radius is only as big as my living room or half my driveway kind of thing. So it's not a very big circle, relatively speaking, to already be at get the degrees of almost 180. So what happens is this circle gets bigger and bigger. Now we need to use our imagination a little bit and imagine we just keep adding rings and rings, and this circle then has the radius of a mile or a kilometer or 10 kilometers, or we just keep thinking about that. Say we just enlarge this circle using the same scale. I've actually made some little circles here that represent these circles right here. So I can sort of turn them around, start playing with this geometry a little bit. Say we made a bigger circle that had the diameter of the entire Earth out of this same scale sort of units. So now the edge of this circle, as we look at it, it's going to be coming very straight up and down as this edge just kind of gets flatter and flatter. If we're only looking at this little section of, say 15 of these circles piled up on top of each other, as this circle gets larger and larger, these become more and more up and down. Imagine if we went from not just the diameter of the Earth, but a circle that had the radius from the Earth to the Moon, or from the Sun to the Earth, getting bigger and bigger, or let's just go really big, our whole galaxy, a circle as big as our galaxy made up of units like this. So now we're thinking really big. What's going to happen is the edge of this circle is just going to be a straight up and down row of these sort of units here, and the actual curve of the circle is going to be happening in between, sort of along the inside of this line right there. All those angles, 179.9999999, a whole lot of nines, is going to be the angle. So that curve is going to be sitting in there, and when we eventually get to a place, as we keep enlarging the circle and focusing in on the very edge, we're going to end up in a sort of a geometric place where it's just straight lines and angles that are units of this here. So I'm going to show you what that looks like. I've done the geometry of this on the back here. So I'm going to flip this around and show you what that looks like. Okay, so there it is. Basically, this is the same size circle as this. It has the radius of point A, root 2. Remember, the diameter of this is 0.96 root 2 with a 0.03 root 2 on either side, little gap. So the radius of this little circle here is 0.49 root 2. So this is how this fits in here like that. And as I was saying, now that diagonal of these all stacked up each other's at an edge. But you can see we have a nice straight line and the curve of the circle. You have to really think the scale. This is where you have to use your imagination and think that we've gone very, 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 very small here. So you have to, again, start thinking, okay, what does this look like? Well, what's interesting about this, and I haven't drawn them in here, but if I was to make a circle inside here that just barely kind of overlap that little square root of 2 edge, we have circles that have the diameter of 1. It's 12 little squares along here. So now we got into this place where we have 2 components, and this is really what I've realized pi is made up of, actually 2 different components of the universe. I'm going to sort of say solid and empty, because this is the question. We started off, our diameter was made up of these circles here, a row of them all touching each other, and we took those and then we spread them into the circumference, and then we have this gap between them. And initially we had these circles were sort of on the outside. We have 2 rings, and then slowly they came closer and closer until we get to this point here where we've got a whole field of these sort of circles here with a lot of empty space between. We're in another realm, and the question is, how do we get back now to having these 2 circles, the geometry of these, fitting back into being solid units? And actually, I realize this is the question when we think about quantum physics. We're in a place that's so very, very, very small. The scale is so different, and there's a lot of empty space down there, and yet somehow all that empty space kind of joins together and overlaps and builds up upon itself in terms of electromagnetic waves and energy and particles and atoms and molecules and the chemistry of physics into the solid matter where we are, where all that space kind of disappears, but we know that it's inside. If you were to think of this imaginary ring that we have that's as big as the galaxy, it still has all these empty space, all this empty space between. It's got these, all that empty space is in there, but it's evenly dispersed throughout the circumference of the circle. If we were then to take that huge circle the size of the galaxy and shrink it down to like a ring that I could put on my finger, then all that empty space would be evenly distributed throughout the circumference of the circle. I believe that's the correct geometry to explain the relationship between the empty space in the very small and the solid matter that we perceive in the universe around us. And our current value, or our current model of a solid line, 3.14195 or whatever it is, of pi with a little gap at the end that can't quite be filled, and just putting all the numbers in that one little space, a crack in the line, is not as good as of a geometric model as what we have going here. Okay, so I think I'm just gonna leave it like that for now. I'm gonna go into some interesting geometry here in the next video. I just wanted to introduce that idea of, or really clarify, show you where we end up. This is like the coordinate plane for the quantum realm. I'll call it that. So let's leave it at that. Hope you enjoyed this video and hope to see you in the next one. Thanks for watching.